So last week, we discussed about end-to-end machine learning process using a code example, and so we executed some of the steps. And what I did today was I started and rerun, initialized, connected to a hosted runtime. This is in Google Colab, and I shared this notebook last week. So last week I started on this notebook, and I shared the notebook in the Google Drive. So you can still find it there, and run it for yourself, go through the code, learn what each line of code is contributing to the overall process, and understand it. Now, just to quickly go through the notebook, the first line is to check if the environment is working with Python code, with welcome to machine learning, and then we are importing the system package and checking the system information. And then we checked scikit-learn, or sklearn is an important machine learning package, Python package, and we imported it, checked the version to be greater or equal to this one, and we checked actually our version is 1.22. And now the next step was getting the data and downloading the data. We got the data in this format, and then just the housing data. You remember we had that, and we did quickly check the dimension of the data, the shape method on the housing data frame. This is a housing data frame. The housing data frame, that shape, this is the pandas data frame, by the way. The pandas data frame, this is what we get the pandas data frame from. Like the pandas package has got the data frame that contains the data in a tabular format, and this method actually reads the data from its source and returns as PD, which means a pandas data frame. And as you can see, a powerful data analysis tool. I hovered on it, and then just it gives you reading about the details of this PD means, which is pandas. And the housing is the return from this method, because we are calling this method here, if you see, right? So this is the method called, which is this method or this function, which we define and just have the details to read the data from its source. And now we did a quick look at the data. It starts from like we can do shape. Shape gives you the dimension, the number of rows, comma, number of columns. The number of rows are 20,640. The rows are 10, and it goes on like this. And just more details about the data dictionary looks like this. The data dictionary looks like this. The columns and each of the columns, whether or not they have null values in them or not, you have these details here. Of all the columns, ocean proximity is categorical because it says object. And as you can see, ocean proximity is island or some categorical value. The rest of the values are numeric. That's why you see flow 64 all the way down here. So we saw the data, and then just we did a value count, the distinct value count of the ocean proximity. For example, like the ocean proximity is a categorical data, as we said. The values are island, near ocean, near bay. So these were inland and island. So these are the 4 different values, categorical values of the ocean proximity feature. And then just the other one is the population, the housing population, population. And just we have these values and how many, the number of rows containing this number of values. So it goes on like this. And then just we did so much of it. So you can repeat. I hope you have already if you are properly following this notebook, you can execute every line or the entire cell and see the result and inspect it manually. And one other thing that we did was creating or plotting graphs. For plotting graphs, this is an important package. The matplotlib pyplot, which usually gets imported as the PLT. So this is just an alias or a small, just a shorthand name of this package. So PLT, and just as you can see, PLT is used in many places, right? So PLT, which means plotting. So we use the plotting to create histograms. So this is the method that makes it the diagram histogram, right? So a histogram, it tells you make a histogram of the data frame's columns, right? Beans 50, the figure size 12 by 8. The figure size means the lengths, I mean the height and width of the graph. So the fig size. So we have all the attributes plotted as histogram with their corresponding values in them. And here in this code, we said save figure, then just this value creates a figure, like just this method creates a figure and saves it to the current working directory. As you can see, so here we have image, and the image end-to-end folder is the folder where we are saving, and all the plots, for example, attributes, histogram plots is the first diagram, the first diagram. So the first file in this. So we are saving everything as like this entire set of images as one file. So just every plot can be captured as a file and saved. Now here we used multiple methods. If you remember last time, we used different methods to create a test set. A test set, one, you can have your own method written here and use this same method here. So we are using this shuffle and split the data into a given data into test and training data set. So as you can see, if you remember, I mentioned last time that Python methods can return multiple values. In C#, we used to have like one value only, or in C#, Java programming language, we used to have only one values to be returned. Today, both these languages also support multiple values as returns as tuples, but without just putting them in a tuple format. Python returns, if you see return, and then you have this 1 and 2. So these two values are the return of this particular method, and these two values get returned, and these two values are just the variables that capture the return value from this method, the highlighted method here. This is the code of the method with the housing data set and the testing portion or the testing ratio to be 0.2, which means 20% of the data to be used as 0.2. And then what that means is 80% for training and 20% for testing. So the shuffle and split method returns two data sets, the training set, which is 80%, the testing set, as we provide a 0.2, which is 20%. Then, as you can see, the training set out of nearly about 20,000 records, because we said we have 20,000 records, right? We created the dimension 20,000 records with 10 attributes. 9 of them are numeric. The last one is the ocean proximity is categorical, with just out of the 20,640, 80% of them, 80% of that data, when we split it, is 80% of the data is in training set. 80% of about 20,000 records is 16,512 records. And the test, which is 20%, is 4,000. The sum of these two, this and this, add up to 20,000 records. And now we said let's use a magic value as in the random seed. And we also created the cyclic redundancy check for error detection to detect errors and to be used by upper protocols. And for that, we used this method. In any case, we approached the training test split again from a different perspective. So this is another approach. So we had like using the hash code. We also approached, we wrote another split method using ID hash, which is a second method of splitting data into a testing and training set. Then just again here, 20% of the data to be training, testing, and 80% of the data, which is housing with ID. The housing with ID is, so we have, we used an ID column, and then just we split it to testing and training. Another approach is using the out-of-the-box method. Instead of writing our own, or instead of reinventing the wheel, the sklearn or the scikit-learn library, which I said is an important library in data science or in machine learning, using pandas data frame, is the sklearn package. The sklearn package has got a model selection class in which we have the train test split method, and we can use that out of the box method. Using this out of the box function, we can simply just pass the data set and the test size, which is 0.2, which means 20% of the data to be allocated for testing. And then the random set, this is a number, that the magical number that we usually pass to make the this split, repeatable without any issue. Then the training set and the testing set will be returned from this method. This method as the same as the method that we wrote earlier, which returns two values, for the training and for the testing. The standard method also returns two values, the training set and the testing set, which are our targets. Again, we check the length of the test set, the same number got returned. Now, the other approach is the other area that we checked is creating histograms on the income categorical value, the income categorical value, and then just we plotted the bar chart. The bar chart. This is where the type of chart is identified, and the grid is true. That's why you see like the grids, the horizontal and the vertical grids on the graph, and then just we also labeled. So plot X label, Y label means labeling the X-axis, labeling the y-axis. The x-axis is labeled as income category, and then the default direction is like just from the bottom to top vertical for y labeled number of districts, and then for the x horizontal income category, here income category, and then just we plotted this bar chart. The reason why we are plotting, we use graphs is to visualize, to see the pattern. And as you can see, the income category, there are the income categories were identified. You know, income category is created from the median income, and the median income is created by using beans from 0 to 1.5, from 1.5 to 3.0, from 3.0 to 4.5, from 4.5 to 6. So we have 1, and then 2, and then 3, and then 4, and then 5. So we have 5 bins I identified with labels 1, 2, 3, 4, 5. So we basically just split the income, the median income, into these values. So so these values are corresponding to each bin, and the bar chart is created. Now, again, we discussed about stratified shuffle split. We can also approach the training and test split as stratified test, and we can stratify using one particular attribute, which is income category, and then stratifying the test. You would see the details of each, the percentage of each set. And then like just computing the data for we can see the percentage of income category, the overall percentage, the stratified percentage, the random percentage, stratified error, and random error. So this is one way of checking or splitting the data, our data set into test and training. So the advisable step to use to split our data is the train test split of the scikit-learn. And as we have the train test split from scikit-learn, here we have, yeah, so we imported the train test method. Going up. So we imported the training test split function from scikit-learn's model selection class or package. Then we used it. Similarly, other machine learning libraries have this capability, this provision. They basically provide you a method that enables you to split your data into your data set into a testing holdout and a training data set. So you can use. That's what I advise. So just the other methods are way of showing the internal implementations or internal details of these methods. Now, the next step is discovering or visualizing the data to gain some additional insight. Remember, so in our initial discussion, we had this, the CRISP data mining process, the cross-industry standard process for data mining, right? So in cross-industry standard process for data mining, we said we need to understand the business first, and then we need to understand the data. So in trying to understand the business, we identify the source of the data, and then just data understanding follows. In data understanding, what happens is creating insights, creating visualizations so that we can understand, we get some additional insight about the patterns in the data set. So that's the reason why we are basically doing what we have been doing on this particular data set. So visualizing geographical data is way of trying to understand the data. And if you remember, we plotted this longitude and latitude. We also mapped this longitude latitude with heat map and showing that the percentage is, I mean, the color shows this detail, the median house value, as just the blue is lower median house value and the red is the highest median house value, whereas the values in between are what it means here. Like just the yellow means kind of midway, the greenish yellow is about the midway of the median house value. So on this longitude and latitude, since longitude and latitude plottings are geographical plottings, you can basically just project them onto a real land landmass. So this real landmass, as you know, this data is from Californian data. So this landmass or the longitude latitude graph was mapped onto California. So this is the California on California map. We basically just got this plotted, and as you can see, it shows, and the median house price around the coast is higher. The reason is in US, most people like to have their house, especially just well-to-do, to build their house or to buy their house around the coast to enjoy the nature and like water views. So that's the reason why just houses near the coast, the median house value of houses near the coast is higher, which is like just reddish, more reddish than bluish. Like just a blue are within the land, right? So houses inside the land are more bluish, and these areas are a little bit special because like these are very sophisticated city areas. And the other thing that we checked was correlation. And correlation means just checking two variables, taking every two variable and checking whether or not one is dependent on the other. You might have already taken a statistics course. In statistics, there is Pearson's correlation coefficient, and Pearson's correlation coefficient value goes from -1 to 1, from -1 to 1. The -1 means they are highly correlated in just in an opposite way, which means while one variable increases, the other variable always decreases with a consistent pattern. That's -1. +1 is when one variable, the value of one variable increases, the corresponding value of the dependent, the other related value variable increases. If both are increasing in equal proportion, then just the value becomes 1. So as you can see, longitude with longitude is 1 because it is highly correlated. Just every variable is highly correlated, and the values in the diagonal are values that show the correlation between this one variable to itself, right, in the diagonal. More values here in the diagonal, which is the last value is the median house value to the median house value. But you can see other values that are close to 1. For example, this value, the households is highly correlated with the population. Households, when the population is so high, obviously the number of people that could live in one house is expected to be higher. Obviously, that's what we see. The total number of rooms is also correlated with the households. Sometimes, just most of the time, when you have more people in a house, then you would have more rooms. So these are the type of correlation or relationship between these true relationships. And another 0.8. Now, just I'm simply checking values close to 1, and the total number of bedrooms is again associated or highly correlated with the number of population, obviously. And just how about the negative? The latitude, longitude. As the latitude increases, longitude, this is kind of area. We don't consider this as something that we can control, because in the case of California, as the latitude increases, the longitude decreases. So this is geographical value. Another interesting correlation, I think that's enough. So in the main point here is which variables or which features are related to which features. And the reason why we do that is if the correlation between the two variables is either close to 1 or close to -1, we can take only one of them. For machine learning. So in the case of, for example, like just this one, and this, we can take either the one of the variables, like for example, 1, 2, 3 variables are related to the household variable, highly correlated. So these were the things that we saw last time. Now today, this is another scatter matrix diagram, again from pandas plotting package. We got the scatter matrix function, and then just we created scatter matrix graph for the median house value, the median income, the total rooms, and the median, the housing median age. And the figure size is 12 by 8, and we have this. We have 1, 2, 3, 4. As you can see, with this way 4 and down 4, because it corresponds to the number of attributes that we chose. And just diagonally, you can see the corresponding the values. Just this kind of repeats itself up here, and on the way we see the scatter matrix kind of flips when we change the values. And this is a median income by the median house value. So this is how they are related. And just this is another way of looking at the values that we just checked here in number. Instead of in number, we are checking in terms of scatter plot using the data points, and then just like the pattern, how the direction of the data flow, the direction of the data flow. Let's do and just run this one. Here we have the median house value and the median income. As you can see, the median house value, as the median income increases, the median house value, or the people owning houses with higher median income will have a higher house value, or like just the price of the house is higher in this scenario. This is kind of an indication. So the scatter plot gives you insight about how or where the direction of the uh, how the data, I mean, what kind of detail the data shows. As you can see, if we draw a line, we can draw a straight line right here. And these tells us some sort of regression. As median income increases, then the median, like just people owning houses, uh, uh, or the median value, or the median house value of those people with higher income will be higher. So it's that's what the data shows us. So the scatter graph is plotted to show this. And another experimentation with here. So again, going back to our initial, now just we are trying to understand data, and we are also preparing data. In data preparation, if you remember, like just we also mentioned that the feature engineering means creating new features, using existing features, The way we create new features could be by manipulating, using mathematical formulas, or manipulating one or more attributes together, and then we create new attributes. That's exactly what we do. So here, so here, for example, rooms per house. This attribute doesn't exist in the data set. This attribute doesn't exist in the data set. And bedrooms ratio doesn't exist in the data set. Population per house doesn't exist in the data set. But what we're doing is just creating this room per house using the total number of rooms and the total number of households, or like people living in the house, and rooms in the house. Then just this ratio is generated out of using two values. And bedrooms ratio, again, the total number of bedrooms and the total number of rooms. You can have maybe in a house, you can have 4 rooms, but all 4 of the rooms may not be bedrooms. So just this is why we are calculating the bedroom ratio. And again, the population, the total number of population in the area, and in the household. So let's create this. So running this means adding this additional attribute into the housing data set. Now, again, let's see the correlation matrix. The correlation matrix shows us this, the housing correlation matrix, and then just simply check, get the correlation matrix for the median house value. The median house value correlation matrix, the median house value with itself is 1, but with median income is 0.6, with rooms per house is 0.1, and just we are sorting in descending order. In descending order, the highest is the median house value correlating with itself, which is 1, always 1. Just a matrix, like a correlation of a variable with itself is always 1. So that's what you see right here. But the median income is about 0.688. The median income and the median house value were graphed here. The median house value and the median income were graphed. This is why what it means. 0.66688 value is also created here. And the other thing is the bedroom ratio is one of the new features. So one of the new features, and the other new feature is bedroom per house is 0.14. Not correlated is a good idea. If it is not correlated, if a new variable is not highly correlated with existing variables, that's good. Again, just this is a good sign, which means the attribute or the variable, the newly engineered, the newly added attribute or the feature that we engineered is of a great value that we could use for machine learning process. And now preparing the data for machine learning algorithm. Again, going back to this graph, so preparing the data also requires to close DC. In data preparation, we did feature engineering, which means feature engineering means adding new features like the median, the room, the bedroom ratio, right? The people per house, like this, the rooms per house, the bedroom ratio, the people per house. These three variables didn't exist in the dataset, but we added them into the dataset by manipulating existing features. So this is feature engineering. Now, so let's reverse the original training set and separate the target. The stratified training set. So let's do this. Let's do this. So I'm going to run this. So the housing is calculated. So the housing stratified training set drop median house value at axis 1 means drop this column from the stratified training set and then create a data set. What this means is drop this method does not drop this particular column from this data set. Instead, it creates a copy of this data without this attribute in the data set, and then just it keeps it in a housing variable. So this is a data set without this, the same data set as a stratified training set, but without the median house value column. Again, the housing labels are copied from the stratified training set with median house value. So now we created the housing data and the housing labels, the housing data and the housing label. So these were the training set, the same training set, right? It's the same training set, one without the median house label and the other with just only the median house label. This simply copies this particular column, only one column, or like I can quickly show you. If I show this, it contains two columns. This is our target value. And this is the index of the target, the single column. However, if I say, just if I print this, everything will be printed except the median house value. The median house value is not included in here. If you see, or if I say shape, you will see 9. Originally, we had 10 because we dropped this median house value from the training set. We only have 9 attributes, and then the total number of the data in this data set is 16,512, which is the training portion, 80% of the data, right? 80% of the data. Now we are getting closer into the data set. Now here we have data cleaning. So in the data cleaning, we can do like removal of MPT columns, like just drop NA means remove uh, uh, like empty columns, and empty remove rows containing empty values, and then the subset is total bedrooms. In total bedrooms, if we have NA, then just we basically remove the entire row, and that change happens in place. True means the housing data set is going to be affected, right? It's going to be affected in place. So just we are modifying the same data set. Or the other option is the housing drop total bedrooms and axis. So axis the same. This is the same, and this method is by axis one. Just drop. Okay, if this must be drop NA, okay. And or the other option is the total bedroom. So drop NA entirely. So this must be like this. Okay, so this must be drop NA. And the other is the median. We calculate the median value from the housing. This is another option. When you are dropping a data set, you are reducing. When you are dropping rows because of data cleaning, you are reducing the number of columns. And potentially you could remove when you are targeting only one attribute, which is a total bedroom, in which is one attribute in the total bedroom. And because of that one attribute, the total bedroom attribute, even though the remaining 8 columns have valid values, then you might end up removing the entire row from the data set. So instead of doing that, just you calculate median from the median value of that particular column, which is calculated as median, or you can also calculate the mean value, of the data set. But just here we chose median. Then you can, instead of dropping empty columns, you basically do fill the empty columns with the median value, right? Instead of just wiping the entire row, keep the row, but wherever you have a total bedroom empty, fill that empty place or replace the empty with the median value of the column. So this is an approach. So for each option, we will create a copy of the housing and work on the copy to avoid breaking housing. So the housing, we are basically just creating a housing is null any axis one, null row index. We have a null row index, and then just let's see what happens, right? In okay. So the null row index means in the housing column, if any of the in the housing data set, if any of the columns, if any of the cells is null, we are basically just creating the null row index, and as you can see, the total bedrooms is any none. So just none value means uh, the rows where you would see, and then just we can also see how many values we have here. How many null rows. Okay. Okay. Here, length of this value tells you how many rows. There are 16,500. So since we are basically checking and everything, it tells us wherever there is null, which means null is across the data set. This is the total number of the rows across the data set. But we can check the housing, and again here, yeah, again here we can check, and instead of basically like just dealing with, we can deal every null value from each column as we used these different three options. Option one, removing the entire row in place, or option two, the same approach, dropping NA. Okay. I am sorry, there was some network glitch on my side. On my side. So I noticed probably you might have failed the same on your side, but I'm back. So here we have the data set. And then just anyways, what we're trying to do is cleaning the data set. So in cleaning, using option one, we created the housing data, the copy of it. And then just with option one, we are dropping the total bedroom in play. We are dropping MPT rows with MPT sale value of the total bedroom. Then, so that's, and if you see here, so this is what it will look like. There is nothing I see. Iran, there is nothing that I see. No value here. Okay. Okay. So not well, this is wrong. This is wrong. This should be this because we are not using it. So we need to check this because we are using option one and targeting the subset bedrooms and dropping any values. Maybe we can, so that we can see the headset, and if we see the shape, it could tell us, no, not here. It could tell us the number of rows that were affected. Shape, and there we go. You see, the original data set had, or the housing dot shape had this many records, 16,512 data sets. But after manipulation, after the total bedrooms, MPT values in the total bedrooms column are removed in place, the housing option 1, which we copied from the original data housing, which I checked right here, and manipulated by removing MPT values in the total bedroom. In the total bedroom, not only did we remove the MPT cells, we entirely removed the row from this data set. That's the reason why the rows got reduced from 512 after 16,000 to 344, right? So this is a difference, the difference. So this many records were affected, which is the difference between 512 and 344, right? About 116, 168 records were removed because the value in the total bedrooms were MPT in the 168 rows. So just we entirely removed the rows, entirely removed. The issue was the total bedroom. This bedroom was empty. How did we know? Because so this basically just the drop NA in place manipulated the data set. The other option is just we created option 2 from the original data set, and then we are dropping this, right? We are dropping this, and then just let's see what happens. Let's see what happens here. And as you can see, the housing, the total bedroom column doesn't exist. In option 2, the total bedroom. I think the note that I updated here was not right. It was intended to show another option. Instead of drop NA, it was drop the column itself entirely. So you drop the row containing the MPT values, or you drop the column containing the MPT values, the column, not the row. Or the third option is you replace the MPT values with some calculated median value. So this is and so in option 2, in option 2 we removed the column. And as you can see, the shape in option 1 was then the rows were affected, but the columns were the same. In option 2, you will see what happens here. In option 2, if I say dot shape, the rows remain the same. Okay, I think we manipulated option 2 from. Oh no, yes. So no, this is option 2, sorry. Option 2, then it remains the same number of rows, right? The rows remain the same because because the column or the feature contained MPT values, we totally dropped the column itself. So the number of columns reduced from 9 to 8, but the number of rows remained the same with 16,512, and instead of reducing to 16,344, which was in option 1. And the third option, again, let's see the third option. You copy the data, the original data, to a third option, and in the third option, we calculate the median value of the total bedrooms. And then instead of just, modifying either the row or the column, we fill or we replace. So let's see what happens. So the total bedrooms is still there, right? The total bedrooms is still there. And then and they were replaced with median value. And what this gives us is option 3 dot shape. This shows you a data set containing everything. The 16,512, all the rows and 9 columns. So the option 3. So you can choose which way to take depending upon the number of records. If you remember, when we were manipulating earlier, we noticed that only 168 rows were affected, right? 168 rows had empty values. So if the MPT values are just, so high in number, maybe like just 60% or more, you may consider entirely removing the column, or if the percentage of the MPT cells in a given column of the dataset is very low, you can keep the column. But remove the rows containing those MPT values. Or if you want that rows to remain intact, you can replace the cell values with median values like this. So that this is called imputing the value. So there is an out of the box imputation or in scikit-learn. So you can use a simple imputer. So here we calculated manually, right? We calculated manually. But if we use the imputer technique, we can basically just use imputation. We can create like a model which we can use on the data set. And as you can see, when we create the imputer, the simple imputer, we're saying that let's use it as a median calculator, like just wherever we see missing values, if we use this model that does calculate, what it does is it basically calculates a median value and then just replaces it, searching out the numerical attributes to use a median strategy, as it cannot be calculated on text attributes like ocean proximity. And ocean proximity is a categorical value. So for categorical values, we don't have median. Median is for numeric values. So so here, what we're doing here is we select housing. From housing, we are selecting attributes whose uh, uh, data type is numerical, or NP number means this is a numpy number, numeric value. So then we do this, and the housing num is the entire data set. So if you see here, the housing num is the entire data set, but with 8 columns. Why? Because the 9th column is not numeric, the ocean proximity. This is will return all the training data set, but without this column. because it is numeric and it is categorical. The reason this housing num is created by this method from the original dataset. The original dataset, we are selecting the columns of data types having numeric values. So as you can see, the ocean proximity contains categorical data. So now, once we have these numeric attributes, then just we can simply impute housing. So the imputer was the one that we have here. The imputer is a model, a simple imputer model, which calculates the median of the data, the numeric attributes or the numeric column, and then just fills the data set, fills the empty columns. Now, what happened? Imputer. Okay, I think I didn't run this. Yes. So you see, this line was empty. I didn't run this. So this is where we create the imputer. So see 68, then this should succeed now because the model is created. Now the imputer is created, then and then the statistics gives us the following. Here we go. Right? Here we have. And for each column, we are calculating the median value of each column. 1, 2, 3, 4, 5, 6, 7, 8. So for each of the columns, the imputer calculated the median value. And just you see, this is a one line, just a model that we created. And then we can use this imputer and yeah, okay. And then just we applied even on the housing data set imputer. Then the housing, the median values, if you see the housing median values, you will find exactly the same value here, the same value. The median value remains exactly the same as whatever the imputer, because we used the imputer to fill the data. Another approach is data transformation. We can transform the training data. So as you can see, the median value was manually calculated here, but the median value that we got here was using the impute technique from the scikit-learn. So all in all, what we were trying to do is to basically just manipulate and fill or do data cleaning. And I'll come back to this in a summary. This is a practical approach that you could use. I don't know if there is any question so far. Any question? And my questions are, is missing data management a part of pre-processing? If so, shouldn't we manage missing values before the data set was split to training and test does the nature of missing data, MAR, MNR, MCR, matter whether we impute or not missing values in machine learning? What is can nearest neighbor imputation technique? Okay, good question. Good question. I saw people doing this same mistake, and in one of my classes at University of Washington, I happened to see another person creating the same technique. I am simply following the notebook that is created by the book, created for the book. This is part of a book which this is the chapter 2 of a book, end-to-end machine learning project. So I'm simply following the book. Yes, you're right. We shouldn't have to split the data into training and test before cleaning the data, because data cleaning, especially like just if we are calculating the median value and then using that median value for cleaning, we have to use the same median value on the testing as well, on the test data set. Otherwise, we shouldn't have to clean the data set before splitting. If we are treating null value handling separately, we are creating two different scales for the data sets. The training data set is being manipulated using one scale, and the testing data set is going to be manipulated using another scale, which creates mess. So you're right. So we should be very careful not to manipulate the data set after we split. It's important. It's better to do the training and the testing cleaning, like just data cleaning done to get just on both the training and the testing data set. And another point that I have to call out is any step, any process that you are following for data cleaning should be properly documented and should be consistently used for new data during data machine learning training. During a machine learning training, you would be manipulating, especially just data cleaning process. You may use one technique for cleaning your data set, both training and testing. That same technique has to be applied on new data sets as well when you are using the model. So just a very good question. We have drop column in case of NaN value, or we have to drop a specific NaN value from column. What is the rule of thumb before dropping column? Yes, the rule of thumb is checking how much portion of your data is going to be affected by your action. And this means you may, if you are dropping the data, the column, you entirely lose all cell values for all rows, right? The entire column gets dropped. That's one option. That is advisable only if your data set, your column contains insignificant number of non-empty, or like just majority of the column values are null, then just it's advisable to drop. For example, like just more than 60%, 70% of the column, if they are empty, then just drop them. But if it is less than 40%, right? If it is less than 40%, 30% empty, you have to deal with that. If you are dropping rows, also the same. When you are dropping the rows, you may just in the process of trying to clean some mess in one column, you may reduce the entire data set. So just it is important to note a domain specific knowledge to consult a domain specific expert or read more about the impact of your action on that particular data set. We don't drop the specific NaN value from the column. We either drop the row or drop the entire column, vertical action or horizontal action. That's what we do. But just before doing that, we need to consult. What's the difference between imputing median values and mean values, missed values? Okay, so sometimes it's kind of disputable. Mean values get affected by outliers, right? If you have an outlier, the mean value tends to move to the outlier value. If it is like just a small outlier value, it moves to the that, or a higher outlier value, it moves up, right? So mean is affected by outliers. Median is not affected by outliers. Median is simply like just the middle value of the total number of records that you have, whether you have many outliers or both on the low end or the high end, it's not affected. So that's the reason why median is sometimes chosen as the imputation value. So let's go down. These are some of the questions that I saw. Then what if we used those missed value deliberately for training and test? If someone knows only some feature while he or she want to predict the new instance. I didn't get that question. We don't use missed values deliberately. Missed values affect your training and testing process. So just they have to be handled properly. Otherwise, your maybe if you are intending to use a missed value as one of the target values, you have to represent it in a certain way. But missed values are missed values in any measure. So until another question comes, I will go down to where I was. Okay. Now, so here we were here. Okay. Thank you very much, Baizo. Your questions show how close that you follow. So great questions. So another way is transformation. So just we can create the imputer as a transformer. And then we can the feature names like are the longitude, latitude, housing median age, total rooms, population, household median income. So everything is there in the imputer. We transform it, and here the housing training, we are basically just creating a data frame using the housing the numeric value of the housing columns, and then just using the housing index. Then you can see the data right here. Okay. Yeah. So the x value is the imputer transform. So and we are basically just putting x here, and so to see the shape of this, we can still see shape. So the same number of records. This is another way of data transformation using the training data set. And imputer strategy, it will tell us what kind of strategies that we used, which is the median, because we initialized it up here. The strategy was used here, and then we have been using the same strategy. And here, numeric columns, index, I think this is the same. Okay, so now this is the same. This is the same. So dropping some outliers. Now we just another data cleaning that we should do is identifying outliers, identifying outliers, and dropping the outliers from the data set. To do that, we have just an algorithm in scikit-learn. That algorithm is called isolation forest. Isolation forest is a type of algorithm that we can initialize and that we can basically feed to our data set. The data set that we have is X, which is the imputer data set that we created right here. X, the imputer data set that we have right here, and we can go and use. So this is basically just a machine learning based data cleaning. Isolation forest is an algorithm. That algorithm is initialized as this, and then we identify the predict outliers prediction. How? By fitting fit predict of this data set. So the outlier prediction gives us the outliers of each column. Let's see. So -1, 1, 1, 1, 1, 1. So these are this is the array, and let's see the shape, not the value. The shape gives us this much, 16,512. Is the same, and the value outlier prediction value is -1 to 1. If you want to drop outliers, you would run the following code. Then basically like just housing levels, outlier prediction is equal to 1. So -1 is not outlier, 1 is outlier, 1 is outlier. So just you would see this. And then just if we want to clean the outlier, we can run this this method. I prefer not to run, then just go through the remainder of the code. So cleaning outliers can be done using this approach by using isolation forest and by predicting it, and then by basically just following this approach. Another thing is handling text and categorical attributes. Categorical attributes are important attributes, and some of the algorithms that we use in machine learning don't basically like categorical data. In that case, we have to convert categorical data into numeric data. So let's pre-process a categorical input. This ocean proximity, here it is. The ocean proximity, we have ocean proximity, this nearby, less than ocean, inland. So these are the top 8 values, right? The top 8 values of the categorical data. Basically, just what we did is we only grabbed the column ocean proximity from the housing data set. The rest, the other columns are not included in the housing categorical. So to convert this to a numerical value, one of the approach is using one-hot encoding, or using encoders. There is ordinal encoder. An ordinal encoder can be used to create order, and then let's see. And here, and the encoded values, you see 30114 and if you see here, nearby is given as 3, and that's just the 8 top variables or ocean proximity were given, were nearby. The first is nearby and the last is nearby. As you can see, the first is 3 and the last is 3. The first is less than 1 hour from ocean. The second from the last is 1 hour, and these values are 0 and 0. So just this encoding is creating ordinal encoding, ordered encoding. Just each of these distinct values were given ordered values. This is one approach. If it works for you, this is one approach. There is another approach called one-hot encoding. This approach, the housing, just the ordinal encoder basically just replaces a categorical value to a numerical value by creating order, and then just replacing for wherever nearby is. As you can see, 3 is used, and wherever less than 1 hour from ocean is replaced with 3, and wherever we have inland, it is replaced with 1. As you can see, inland, and then just it jumps 1, and then which was labeled as 4, but it comes back to 1. So this basically creates one column with ordered values. The other categorical data manipulation or conversion to numerical value is using one-hot encoder. So these both are getting from pre-processing class, pre-processing in scikit-learn, both ordinary encoder and one-hot encoder. Ordinal encoder to order, one-hot encoder basically like just to create to add more columns into the data set, and then just you will see how this converts the data. We are initializing it, and then just we are fit transforming the housing categorical value, and then just what does it look like? Instead of creating instead of okay. Okay, we have to convert to array. Let's run this first. Instead of creating like just only one column, one hot encoding creates multiple columns, as many columns as there are distinct values, and then just so and it basically creates a sparse row. By default, the one hot encoder class returns a sparse array, but we can convert to a dense array if needed by calling to array. And so just let's convert it. You see the dense array. Now the dense array gave us these values: 1, 2, 3, 4, 5. The distinct values that we have is 4. 5. So the distinct values, and each of these values will be considered as columns. They will be added. They will be added as into columns. And here, and sparse false makes it easier instead of basically just creating a non-sparse column, a sparse column, and then just converting it to array. You just create the sparse is equal to false when you are initializing the one hot encoder, and then just the same code that we used up here can generate, can take care of every step that we followed. Okay, and now let's see the categorical encoder categories are 1, 2, 3, 4, 5 values. For these 5 values, we will have 5 columns. For however many distinct values in the categories, we will have additional as many number of columns as the distinct values in the column. And okay, so now ocean proximity, island, ocean proximity, nearby. This is how it looks like for 2 values. Only just island and nearby were used, and then we used dummies like this. Now, we basically created this value here. We created this value. So this is another method of one hot encoding, and then just we transformed the using ocean encoder. We transformed the def method, and then just as you can see, we have 0, 1, 0, 0, 0, because inland and nearby are given as values 0, 0, 0, 1, and 0. So just for 0, 1, 0. So since this data set has got only two distinct values, we have 2 columns, the inland and the nearby. So this is 1 column, and this is 2 column. Each unique value here will have. But in the original encoder, although we have these 2 distinct values, maybe like just in a test data set, these 2 values, when we are using the existing column, the existing encoder, which we created here, then the number of columns remains exactly the same, which is 5. 1, 2, 3, 4, 5. So as of next week, I will continue explaining feature scaling, and next week we will have the algorithm. We will be running the algorithms, custom transformers. I suggest you reading through this transformation pipelines and read through this. Transformation pipelines means way of transforming a data set by following a predefined steps. predefined steps, and just the data will go through that. The data gets cleaned, code is written to transform the data, and finally you have a clean data at the end of the pipeline. And then the next step is going to be training the model. I suggest you doing that. Select and train a model will be the fun part of the machine learning. And we will start training linear regression, and also logistic regression. We will see cross validation. What cross validation means, and in the process, logistic randomized search is there. Randomized search is an approach of fine-tuning your model, whereby you can get the best model trained, and hyperparameter tuning. And also there is another yeah, so this is a linear model, fine-tuning your model, which is grid search is hyperparameter tuning, and we will have the having random search and randomized. So again, that is about hyperparameter tuning. And saving your model. So this is an important step. It's just training a model by itself is not the end of the process. Once you train your model, you want to save it and you want to ship it to whoever wants to use your model. So just how to save the model, right? And so we will have this covered in the next 2 classes. And I think I have logistic. Okay, say in a different notebook, logistic regression, and we will also see unsupervised models like a priori and clustering as among the non-unsupervised models. And then just we summarize the notes around them. I wanted you to go through the harder part so that you can easily understand the theoretical. The practical part is somehow challenging. I didn't want to go through the theoretical part first. Then just through the theoretical part, we will basically just summarize what we have learned in the process. So that's what I have for today. And if there is a question, we have a couple of minutes. Okay. I see Achenaf's. Okay, Achenaf, you are allowed. Your mic is allowed, Dr. Achenaf.
Okay, thank you. Can you hear me, please?
Yes, I can hear you now.
Okay, thank you, Dr. Ranaka, for your kind support and for your nice subsequent presentation. Really, it is very nice. It is also very helpful for our project and current development, and I appreciate it all your efforts. I raised my hand also in the last week meeting, but I think I didn't see my hand.
I didn't
It's
see,
not
sorry.
a question. Yeah, it is not a question. In fact, just it is as a group assignment issue what we face from the University of Gondar side. As see, the number of participants is too much, and this is a very virtual platform, and sometimes organizing the group may have a kind of challenge for us. Some of them they request to have group with them, but still it is very difficult for practical implementation. So the review process may have some time taking the process. I kindly request you to accept an individual assignment and review that individual assignment, and if it is possible from the University of Gondar side, because we face a challenge to grouping and getting that group members at one point and doing an assignment. So if it is possible, can they make an individual assignment and can submit for you and evaluate, so it has time taking. Thank you.
Thank you, Dr. Achanaf. Yeah, I think that's a valid question and great one. And I hope this is not only from University of Gondar perspective, but other universities also reached out the same way, like just individuals tried to reach out to me. But unfortunately, it's very difficult for me to manage individual assignments. As you know, there are so many participants. The reason why I asked participants to group themselves and do the project in group was to help me manage just few number of papers than opening the door for everybody, because like everyone wants to submit, and then it's going to be unrealistic for me to let alone go through individual projects, but also like just go through individual emails. Like so I read through, but I don't reply to emails. Whenever like just common issues get raised, I reply for all, addressing those common questions, kind of thing. So for me, I just in short, it's very difficult for me to manage individual assignments. I still prefer teams, folks to work on the group. And the other thing is, although the like the project is is being done in a remote setting, you could find like ways to discuss, like for example, like just Google Talk for virtual meeting, and then just discuss. This is a practical, it has got another advantage. Practically, you will have this kind of team settings that you would have to work with people from other who are geolocated in a different geographic location. So I know just Dr. Achanaf, you know this detail, but probably like my answer is not specifically to your question, but also to, but it is for people who may have exactly the same question. I'm trying to address this. Yeah. And I see Abu, I see your hand, Abu. Did I answer your question, Dr. Achanaf?
Yes, thank you. You answered very well. With this, maybe I kindly announce my message with the team who is available right now. If the participants from University of Gondar, if you are interested to make a group form, kindly send an email till today midday, and I will organize and send back to them if it's possible. Just the message for the participant from the University of Gondar side. Thank you.
Thank you. Thank you so much, Dr. Achanda, for coordinating from the University from University of Gondar side. And anybody who is trying to reach out or creating groups on the University of Gondar side, please reach out to Dr. Achenef. Maybe Dr. Achenef, you may write your email. I hope they know your email address by now. I know Mr. Balai is there from University of Gondar as well. Just you two can collaborate and then create those groups. It is important to have a hands-on experience in the from this particular training. Otherwise, you know, just if you don't, to those of you who are not thinking to do some hands-on practice using this project opportunity, the amount of learning that you would get may not be that enough, unless you know just you make your hands wait with the project. Yeah. Abu, you can speak. Abu, you are allowed to speak, but you are mute still.
Good morning.
Yeah, good morning.
Okay, thank you, Dr. Danako, for your countrywide contribution. You are delivering this course and the training for 6 universities found in Ethiopia. I would like to thank you again, and I have some questions as a coordinator, not subject matter.
Mm-hmm.
We formed 2 groups last time, and I have already sent for you. But one staff is missed because, as you told us, one group should consist from 5 up to 10 members.
Mm-hmm.
Can we make one group 11 members, or what can you suggest for us?
Yes, it's fine. I think just, does that mean that the 2 groups are 10 each?
Okay, so we can add one staff and we can make 11 members, one group.
Yes, you can. I can quickly look up the Jima University.
Yeah, second group.
Okay, so the first both group one has 10, group 2 has 10, and then just you wanted to add one more person to group 2.
Yeah.
I'm fine. Yeah, you just go ahead and add.
Okay, thank you for this.
Yeah,
the other one is,
yeah, please, you can, I see the group 2 list, Amharic to Oromifa, or Oromifa to Amharic language translation, right? This is the project.
Yeah.
Okay, what's the name of the person? Just while I'm right on the, you can huh? No, you can no, the 11th person that you want to add here, write me.
Guade.
Huh?
Abainau
Guade.
Yeah.
Okay, I just Guade. Abainau Guade. I just added his name as a placeholder. Please send me the details, like just the email, the phone number, and remark.
Okay, I will do.
Thank you.
The other one. Last 2 classes, most of our staff needs the class because of the first one is, as you informed by Dr. Warko, because of connection. The second one also because of not knowing the link. I also joined I joined also after 1 hour because of not knowing the link.
Okay, so does that mean that just is this about the first class?
No. The last 2 classes before today, the last 2 consecutive classes, most most of our staff miss it because of this. Just to inform you.
Okay, perfect. Yeah, I think just you
Uh,
you can catch up with the recording, and I will consider in the attendance.
Okay.
Yeah.
The
Any
last,
other question? Mhm.
my last question is, when you complete this course, because except this month, next month there will be exit exam, national
Yeah.
national exam, and so on.
Yeah.
Maybe the student is, I am not sure, as we have experience from last year, the
Mhm.
other students leave the university.
Mhm.
If such cases happens, our students may not stay here.
Mhm.
So if it is possible, we have to complete the assessment course assessments and the final exam before that.
Mhm. Yeah,
So
I thank you, Abu, for bringing this up. Not only for Jima University, I heard on the news today that the Ministry of Education announced the exit exams, the graduation dates, and all those things in Ethiopia. And I was thinking about that. So I will closely watch those dates and consult you, especially like just for Jimma University and Gondar University. We may have to set up like just discuss about the rolling out exams so that you can properly grade the students and evaluate them with the on this particular course before like the
okay,
university in time, in short.
okay. Thank you for providing information for me.
Yeah,
For more information, I will contact you through email. For now,
sure. That would
okay.
be nice.
Bye.
Yeah, thank you. Okay. And I see Samuel Bulti. Uh, Go ahead, Samuel. What is your question? Samuel, you are mute. Samuel, do you have a question? Okay. Okay. Abu, do you have any other question?
No, for now, I have no question. If there is any question, I will contact you through email.
Through email. Okay, good. Thank you. Okay, so I don't know who this person is. Wendumu Wayo. So send me an email, Wendumu, about this. Send me an email. And then thank you. I think it's time. I'm going to stop the recording.